Today I am going to discuss about randomized algorithm. What is a randomized algorithm? An algorithm that uses random numbers to decide what to do next anywhere in its logic is called a randomized algorithm. And randomized algorithm is an important concept which is used in a variety of fields such as number theory, computational geometry, graph theory, and distributed computing. Next, features of randomized algorithm. These features are to be said by comparing to deterministic algorithm. Randomized algorithms are known for their simplicity. Any deterministic algorithm can be easily converted to a randomized algorithm. These algorithms are very simple to understand and implement. They are very efficient. They utilize little time, execution, and space. They exhibit superior asymptotic bounds, and many NP hard, NP complete problems can be easily solvable by randomized algorithms. Then different types of randomized algorithm: randomized Monte Carlo method and randomized Las Vegas algorithm. First we are going to discuss about Monte Carlo algorithm. A Monte Carlo algorithm runs for a fixed number of steps for each input and produce an answer that is correct with a bounded probability. This is simply means that a Monte Carlo method, its output doesn't be correct, but it terminates its iteration in a fixed number. Then Monte Carlo algorithm is used to find out the worst case time complexity of an algorithm. An example for Monte Carlo method is Kager's algorithm, which produce minimum cut, and Fermat method for primality testing. Algorithm for Monte Carlo method: identify the dependent and independent variable and define their domain of possible inputs, determine a probability distribution to randomly generate input over the domain, compute the output for the problem based on the randomly generated input, repeat the experiment n number of times and aggregate the results. We can say in detail. For example, if we have an array with n element, array of A with n element, we divide the array A into half of the element as A and B. We just want to find out the n element from the array. Here we have an argument as array A, size of the array n, and k. K is a number in which we done k trials. The algorithm becomes success before we get output in k trials, otherwise failure. If then I is equal to k, I is equal to 0, we randomly select one element out of n. We take index element. First trial I is equal to I plus 1. We repeat the experiment until I is equal to k or A is to be found. If any one of these two happen, the loop will be exit. Otherwise, we goes to next iteration. This algorithm doesn't guarantee success, but the runtime is bounded. That the number of iteration is always less than or equal to k. The time complexity of Monte Carlo method is peak O of k. The second method of randomized algorithm is Las Vegas algorithm. Las Vegas algorithm is a randomized algorithm that always gives correct result. That is, it always produces the correct result or it informs about the failure. So we can say that the output of this algorithm is always correct and optimal, but the running time is a random number which is not bounded. A simple example for randomized Las Vegas algorithm is quicksort, where the pivot is chosen randomly, but the result is always sorted. Next, the algorithm for Las Vegas algorithm. Here we have an argument as array of A and with the size n. Inside the loop, we randomly choose an element out of n, then check that particular value of A. If we not found A, then goes to next iteration. The loop will terminate until we encountered A. The time complexity of this algorithm is O of n. Next, randomized quicksort. We know that randomized quicksort is an example for Las Vegas algorithm. Randomized quicksort is one of the most popular randomized algorithm. The original quicksort records that all the permutations of the input elements are equally. Randomized quicksort selects the pivot on which to split the elements randomly. Then the result of choosing the pivot randomly is to relax the assumptions that all the permutation of the input elements are equally. Then the expected running time of randomized quicksort is peak O of n log n. And next algorithm for quicksort. Here we have an argument as array, starting index low, last index high. While pivot x is not a central pivot, the pivot element is chosen by using while loop. For that, we choose an index from low to high as x, then find out the smallest element in the array of A compared to x, place the smallest element into SC and the remaining greater element into GC. Here n is the total number of elements in the array. Check whether the smallest element SC is greater than or equal to that of n by 4, and also check the greater element GC is greater than or equal to n by 4. If these both the condition is correct, then x is the central pivot. If not, do the next iteration, choose a random index, perform the same operation as given. Then the partition array low to high around the pivot x. Then we partition the given array into two as first array with all the elements in A that are less than A of x, and the second array that are greater than that of A of x. If we found A of x, then we call recursively in two times that ran quicksort array of low comma SC minus 1, ran quicksort array of high minus GC plus 1 comma high. In randomized quicksort, a randomness is given by step 2, that is, randomly choose pivot element. To avoid the worst case situation, we create the central pivot in step 2. So in randomized quicksort, the randomness is given by the step 2, that while pivot x is not a central point, we randomly choose an element. An advantage and disadvantage of Las Vegas algorithm. A strong advantage, a strong way of estimating uncertainty. Given the correct boundaries, this model can survey the parameter space of problem. Simple and intuitive, this algorithm is quite easy to understand. And disadvantage of Las Vegas is computationally inefficient. When you have a large amount of variables bounded to different constraints, it requires a lot of time and a lot of computation to approximate a solution using this method. So by using this method, the computation is inefficient, that we have a lot of time to compute. And finally, application and scope of randomized algorithm. Randomized algorithm have huge application in cryptography, load balancing, etc. In number theoretical application, we use randomized algorithm for criminality testing. Next, in data structure, hashing, sorting, searching, order statistics, and computational geometry are used for randomized algorithm. Then in mathematical programming, we use randomized algorithm for faster algorithm in linear programming, rounding linear programming solution to integer programming solution, etc. Then in graph algorithm, minimum spanning tree, then shortest path, minimum cut are used. In last, the counting and enumeration. The matrix permanent counting and combinatorial structures are used in randomized algorithm. Thank you.